Okay, now I'll record again. And I'll do the share screen again as well. Now we're talking here. All right, there we are. Okay, sorry about that delay. I don't think I burned up too much time, like 5 minutes. So, yeah, so today we're going to do, we're going to just kind of try to go through and get a little more of a practical sense and of this transaction stuff. And I'll give you a little bit more kind of guidance on what you should know or not know, and not, or not really bother with. So, yeah, we're going to cover all this. Basically, the theory about schedules and you know, with the notion of few serializable and complex serializable, that's important enough that you should know that pretty well. So the recitation is going to reflect that in the DSG. But locks, we're going to try to kind of banish a treatment of locks. We're not going to really talk about locks because it's while they're still used, it's not really the way things are done. So like two-phase locking, it's not. I mean, it's good to know for an interview question, but it's not really so critical today. It doesn't really make that much of a difference. So these, however, you're going to always kind of go back to the SQL definitions of these things, or SQL at least specifications, specs of these things. So this idea of read committed, repeatable read, and serializable. Notice that read uncommitted is kind of kicked out now. It doesn't really come up as a natural isolation level anymore. So that's that'll hopefully be clarified today. And we're going to also go through a bunch of examples on a live database to kind of hopefully get a good intuition of the different isolation levels. All right. So let's go then on to the MV. Let's go on to this guy. And let's do present a slideshow. Okay. So here, just one second, I have to grab something. Okay, sorry about that. All right. So now we'll talk about these kind of how these kind of get done in a more modern way. All right. So so multi-valid concurrency control. We went over all this and kind of gave a good intuition here of kind of what's involved there. Let's see. I should just bring up the chat so if people say anything in the chat, I can see it. Good. All right. So the basic issue is that what we at the kind of fundamental level, what we have is we have two basic kind of modes. We have the snapshot mode, which I think is very intuitive. It's kind of equivalent to basically passing out copies of the database and then letting people work on the copies and then doing a merge later. A read committed dynamic mode. This is a little bit more efficient than the snapshot mode, and what it allows for is it allows for people. I pass out copies, and then they can actually, if other people kind of finish up with their copies and remerge them in, and it's not a problem. You can then actually read those copies from your copy. All right, so it's kind of there's not really a good kind of physical intuition about what it is, but it's just it's got a good implementation. It falls out of kind of the implementation, but basically what you wind up doing is you wind up only reading committed transactions. So this, of course, precludes the whole dirty read problem. So you don't have the dirty read problem. And remember, the dirty read problem is really problematic because if somebody doesn't commit, but you read what they've written, and then you go on and you commit based on what you read, and then somebody else, bases what they did on you, and et cetera, and 1,000 different transactions based on that. But then the original one aborts or rolls back. Then we've got this cascading update problem, and we've lost durability. So we've lost the D in acid. So that doesn't happen when you're just reading committed, right? So reading uncommitted actually can allow for that to happen. All right. So yeah. So there's this kind of gives you some kind of notion of what what's going on. And then there was this whole issue that there was this right skew problem that was recognized in the initial implementation of snapshot isolation. And so then that necessitated this serializable snapshot isolation. And hopefully we'll get a good intuition about that today as we experiment with these things. Okay, so the general way you do this, all right, so are there any questions? Just interrupt me. So the general way you do this is, you begin your transaction, you do it kind of in straight flat SQL. And you basically say begin transaction, and then you set the transaction isolation level as you start the transaction. So in this case, you say like set translation isolation level to serializable. Then you just kind of do your SQL operations, and then you commit the transaction. All right. And different things can happen as you're going through this. Now, this is all kind of heavy duty SQL stuff. There is like another thing also to mention is that if you don't mention the isolation level, but you begin the transaction, then what it does, it'll take read committed is the default isolation level in PostgreSQL. And that can be problematic. And we'll get a good intuition why that can be problematic. So if you, what you wind up doing is you wind up putting up a serializable if you're doing anything really serious. All right. So, yeah, this kind of goes over that, issues with current isolation models, transaction initiation, and commit in current systems. Okay, so the fact is that, it's pretty obvious. We all know this, that people don't, people are using interfaces, and the interfaces are what write the SQL, and the interfaces are what begin the transactions, et cetera. So these things are always accessed through some kind of programming language that's kind of hooked up to some middleware, which is then probably being accessed by, kind of over web, right? Through some kind of server. Through some kind of, there's some client code that talks to some middleware via a web server. And that's kind of how everything actually is getting done. So in that spirit, I want to then show the following demo, and I hope this goes well, because I had to, one of the reasons why I was late today, kind of running late, is I was just putting the final touches on this. So this could go very well, or it could go very badly. Let's hope it goes well. All right, so what I want to show here is, this is just a system that actually I work on, the C-phrase system. That's not really relevant that it's a natural language thing. That's not really what matters here. What matters here is this right here. So we can set inside the actual, this is like, basically this is middleware. This is written in Python. It's middleware, and it accesses the database using, let's see if I can get like some real simple little, okay, I'll say new scratch file, plain text, and then I'll just use charm to bring this over here so I can show you guys notes as I go along here. Uses this DB API 2.0, which is a Python. This right here is a Python convention to access databases. So it's really good, actually, and it's kind of old, but it's really, really good, because all the vendors have basically so the vendors that I've used. Well, it doesn't really matter what I've used. Basically, the main ones are MySQL and PostgreSQL. So I don't know how many people here use Python as your primary language, but you have the equivalents in other languages. But what's nice about these things is they've kind of standardized the whole thing around a notion of a connection, of course. And then what's after, you get a connection to a database, and then you have a cursor, which is coming from the connection. So basically you have something like this. You call the library and you say, basically, psychopg2.connect, and then you have some kind of connection string. So this could be like DB name equals trans1. Can you guys hear me? Oh, is there a question? Oh, no. I like getting questions. See, this would be so much funner it would be so much more fun if we were all in the same room together, but alas. Connection. So basically what you do is inside your Python here, or whatever code you're going to be using, you wind up doing a connect to get a connection. Now, this, of course, I mean, I'll just assume people know enough Python here. But the connection, a fresh connection, this is what you wind up later on. You might say con.commit. So what you're actually doing is the connection that you're doing the commits on. So it's the connections that are kind of the transaction. All right. Now inside here, you would say something like this. You would say something like cursor, or say cursor equals con.cursor, right? So that's giving you now a cursor. So that basically, this is going to allow you to prepare an SQL statement. And then you basically say something like cursor dot, what is it? Execute, I believe, execute SQL, but then it would be something like select star from account. Something like that. And then you can basically say cursor for row in cursor dot fetch all. And I might be getting it a little bit wrong here, but and then print row 1. Okay, if that's a string, we assume that's a string. So I hope you get the idea. So basically what happens here is that I mean, this is not, I can also go in here and I can then say something like, I can do this could be an update. This could be a update account, or I could say, let's say delete account. And then we could say then cursor, then we say basically, okay, execute that. And then we can say again, actually, this is what you can do. Then I believe you would have to kind of say, get a fresh cursor, and then we're going to actually print out all the rows of, well, sorry. Then I say execute select star from account. Okay. Okay, so this allows so that you can you're reusing the cursor. You're just kind of going back and grabbing fresh cursors off of the connection. And then in the end here, you would basically say connection commit. All right. So I hope that makes sense. This is kind of how you would wind up using one of these things in Python. And then other languages are, it's very, very similar. So, but it's really simple. It's basically, you just have the notion of a connection, and then you have the notion of the cursor. Now, I might say something like this. Say, okay, not being very creative here. Do it. And then, of course, what I would want to do is I would want to basically say all this. I'm going to tab this because that's how Python works. And I might then basically say, I might set it up so that do it can be done by multiple different threads. Okay. So, I mean, when you're working with middleware, I'm sure you guys have all heard about this, and maybe a lot of you have experience with this, but have you guys heard, and now I want to get some interaction here because it just sucks for me just to talk. Have people heard about the whole notion of thread safe? Thread safe? Have you heard about thread safe? Have you ever been good? So people, there we have good. I'm so glad to hear that people have heard of thread safe. Is this a thread safe program here? Just I mean, let's make it delete account ID equals, and then let's do this. I believe this will be, I mean, maybe it'll be kind of interesting to see here. ID goes in. Is this thread safe? So in other words, if all these are going to be running, okay, that right there is not right. Or yeah, it is. Yeah, here we go. Okay. let's say that, well, one of the ways that this could be like part of middleware where you have different people coming in to the web server and, and basically calling middleware code that calls us with, and this is the middleware code, and it winds up calling it with different IDs. Is this thread safe? It is thread safe. I'll answer it for you. So this is thread safe, but let's do the following. Global ID, ID offset, right? And I'll basically say that then it's a new idea here that what it's going to wind up doing is it's going to wind up taking whatever the ID that gets passed in here, and it's going to basically say ID equals, okay, ID offset equals 293, and then we're basically going to just say ID equals ID plus 20. So with the idea here, sorry, ID equals ID plus ID offset. All right, so the idea here is that when you put an ID in here, it actually doesn't delete that ID. It deletes an ID that is an offset from that ID. Okay. Now, to make it kind of interesting, what we're going to wind up doing here is we're going to wind up saying, then we're going to basically say ID offset equals ID or something like that. And what do we have to do here? So people who know Python will know that this actually will be fine. So I don't have to do that. I don't actually have to declare this as global, but it doesn't hurt if I do. So if I can say ID offset. All right, is this thread safe? And I mean, you probably can understand that I wouldn't be, if the answer was yes, then it would be like, well, why am I doing this? But so the answer is obviously no. And the question is, why is it not thread safe? And why was the first one thread safe? Because this becomes actually quite important when you write this kind of middleware code and you're dealing with transactions. You know, it's not really that complicated, but basically the idea here is that what if it's kind of like what's coming in here, it's just relying on the stack. It's not really on global variables are usually a really bad idea for thread safety. So you have to be really careful about global variables that change, that is. So if they're constants, that's okay. But this right here, what the idea here is that basically you might have thread 1 who's going to be at line 6, and you might have thread 2 that's going to be at line 9. So the only thing that you can be guaranteed is that when an operation is executed, that it's, well, assuming it's thread safe, then thread safe is just kind of carries on. But basically this there's only the Python interpreter is only going to be executing one operation at a time. So ultimately at the base there is some kind of mutex like property. But basically this is thread safe. This is not thread safe, but let's go back to the one that is thread safe, because I think it's important to keep that. So I mean, writing the middleware, a lot of times when people say something like, well, make this thread safe or something, that's what they're it's because of this because this becomes such a critical because it becomes very important that things stay through. I mean, especially when you're dealing with transactions, because if they're not thread safe and there's some kind of weird state that's coming in, then it kind of blows the whole idea of transactions, right? So what's the big brother for a thread? I mean, you got, let's talk about concurrency for a second here, because that's what we're talking about, right? So so in programming languages, right, we have the notion of a thread. So I can have some server then, that's going to basically, if I have 10,000 people that all kind of call us with different IDs at once, the server can dispatch, and we can in principle have 10,000 threads that are in the same function here, right? All right, so that's a level of parallelism, right? But the we're not going to get any performance advantage out of that, because it's all going to be running on one core, and the Python interpreter lock is going to basically make it so that there's only one operation for each of that threads is being executed at one particular time. So how would we ever have it so that we could actually get multiple use out of the cores? Yeah. So in Python, so there was somebody was talking here about thread safety in C. You use locks. So locks or mutex, or there's lots of different ways you do it. It can get really hairy. One of the ways that's right. So thread safety, sometimes you need to like ensure that. So for instance, if we're actually writing to a log here, like just on the file system, then we need to actually make sure that there's that the function that calls what gets spit out to the log, that is asynchronous. So only one thread can be in that function at a time, because otherwise you're going to garble up what's on the file system, right? But if you can get away with it, so in this case, we don't need to do any kind of locks. We just let since this is so safe, and the only thing that it's grabbing from is like variables on the stack, on the call stack, in principle, like ID here. We don't even have to worry about like making it asynchronous. We can allow for, and we don't want to, in fact, we can allow for many, many different transactions, different threads to be inside this function at the same time. Right? But this is not going to give us any speed up, right? Well, this is not going to give us any speed up in the middleware. Okay. So how do you get speed up? Like, how do you get parallel processing to work if you want to get like things going off to different cores? What is it? There's like threads, and then what's the other kind of ingredient inside of programming languages or operating systems that allow you to kind of put things on to break things up and put them on separate cores? Does anybody know? Can anybody say it, or do you want me just to say it? Okay. Well, there's the notion of a process, right? So you fork processes, and these processes have kind of like a copy of the memory that they were forked from, whatever. And you can play a lot of games with that. And what's nice about that is you can put them. It's more complicated in many ways, but it's like that's the kind of the trade-off. The threads. I mean, threads. A lot of times you get threads for free, especially if everything's really thread safe, or that you don't have to put any kind of asynchronous pieces in, like in this example here. But if you really want to kind of get, use the multiple cores, then you've got to fork processes which land on different cores. All right. Okay. So anyways, this is all just kind of like, this is going to be pretty tedious, but it's like, this is kind of how you access these kind of things. Now, what you wind up doing inside of something like this, since this is where the, since we're talking about, transactions here, set isolation level. Okay. Now, so again, the connection is the seat of the transaction. That's what, like when you this right here, when you made this thing here on line number 5, there's kind of an implicit begin that was started, right? So if you say something like, okay, so now here it's just in at least in Psycho PG, it's basically 0 winds up being an auto commit, which basically means that anytime you execute anything, when you do an execute here, it's doing kind of it's committing. It's doing a commit on that. Okay, so this is kind of like just letting it kind of go willy nilly, just letting the SQL just kind of whatever, who cares? Just let it just execute. You basically kind of are not having transactions when you put it to level 0 here. Level 1, as you might guess, is read committed, right? That'll give you read committed isolation level, all right? And then number 2, you can imagine, is repeatable read, okay? And then finally, number 3 is serializable, right? So it's that simple that you just set the isolation level when you start the connection. Now you can also use the default isolation levels inside of. You can not set it to anything and then hopefully rely on the default isolation levels inside of PostgreSQL. But I think it's better just to kind of grab hold of the thing and have some control. All right. So are there any questions about this? Does it make sense? Kind of, So now what I want to do is I want to show you guys this. I want to show you this working on this C-phrase system here, because this will just kind of give you kind of an idea and intuition, hopefully, about how this works. Let me just shut this bad boy down, and I'm going to restart. Basically, it's called trans1, and let me just launch it on. Just launch it this bad boy on this one particular port. And then I'll go to it, and then here we are. There it is right there. Okay, so now if I say Just loading stuff in. Let's just see here. I just want to see what we had here. All right, so we have a level 0. So we have no transactions now at all that are applying to this. Okay, so let's just kind of go, then we have some illustrious characters in here with money that they've squirreled away. Let's see here. So let's go back. Let's make it a okay. So I hope this makes sense to people. We have, here's one. So I just say account. And then here's another one. So if you can notice, I'm just switching up here. So what we have here then is we have 2 transactions that have both just done a read. Okay. So now what I'm going to do is I'm basically going to transfer 100 units from Blair to DSK. And I'm going to take 100 units from, and then I'm going to, I'm just going to transfer of 100 points from Tony Blair to this Dominique Strauss-Kahn. So how am I going to do that? Well, it's pretty easy. What I'm going to do is I'm just going to go in and I'm going to edit Blair and take away 100. Okay. So I'm basically, now Blair is going to have 900, right? So, and then Blair has 900. And then I'm going to go back here into, okay, now now, as I was doing that, I was also going to be transferring over here 100 units from Blair to DSK. So let's just do that. And that means that, all right, so it already did it. Let's see here. Well, I'm trying to show here is I'm trying to show, see, they're just showing up. So we can get the lost update very easily here. So 900, it's already 900, but I have to restart all this to kind of, this is kind of where I was worried about the problems would happen. So if I basically say, I can do it a different way. I'll do it the following way. I'll basically say, okay, so let's just start over here. And I'll just basically say that what I want here is I want to set amount for Blair to 800. Okay. That's taking 100 away from there. And I also want to, at the same time up here, since this one up here, so that one is going to set Blair to 800. And this one here is also going to set Blair. See, if we say, look, if we look at the account, so both of these are taking, both transactions now are taking 100 from Tony Blair. Okay, so that's the idea. Both of them are going to be taking 100 from Tony Blair. So Tony Blair, oops, Tony Blair has 900 in his account. So this one basically is going to also say set account, sorry, set amount Blair 800. All right. Set amount, account amount. Okay, so this one's going to be, it's going to set that amount to 800, and this one's also going to set the amount to 800. Okay, so what basically you can kind of see what's going to happen here because we're not doing any transactions at all. It's not going to be very nice because what's going to do is it's going to be, okay, it's going to set that to 800. Right now it's 800 there, and it's going to set, this one's going to set it down to 800 as well. And that means that basically it's got to, so this one thinks 100 units now can be transferred to DSK. And this one here thinks that 100 units can be transferred to DSK. So you can see that we're actually going to be, money is going to be missing here, okay? So Blair is only going to be deducted for 100, but DSK is going to wind up getting, so if we basically then say set amount, so now DSK to 1,000, or actually if we just kind of read it, but I hope you, I mean, it's pretty obvious here that this can get us into pretty serious trouble. So for instance, I can have one transaction that says, okay, add 100 to Trump, and well, you know, you get the idea, I hope. So let's this gets more interesting when we start dealing with actual setting when we actually wind up setting isolation levels. So let's go back in here and let's set the isolation here to read committed. All right. Okay, now what it's going to do, it's going to relaunch both of these up here because that's what it does. And let's just say, okay, clear. And then we say account. And we'll say account here. All right, so notice here now it says that we have read committed, we have commit, and we have rollback. So these are the operations. So we've started our transaction now, right? And let's just try to do something like, let's have transaction 1 is going to set the amount in Blair. We're just going to basically take away, this one's going to take away, see now they're running concurrently, okay? So both of these are running at the exact same time, but we're going to go into Blair here, and we're going to give him 50 euros here, okay? And that's done. Okay, so now we have 50 euros. That went through. So now if I read the account here, for this transaction, you see now we have 850 euros, right? But if we go over to this transaction and we look at the accounts, we only have 800 euros, right? Because what's happened here is that this first transaction is making a copy to its private database, right? It's making a copy to its private database. So what happens now when we go over into this one here and we attempt to basically, let's say, set Blair's account to 875? Does anybody have an idea what's going to happen here? All right. So what's happening now is it's waiting on a lock. All right, because it wants to do it, and there's two possibilities. One possibility is that this transaction here, which updated it to 850. There's two kind of possibilities here with this transaction. It's either going to commit, and if it commits, then this transaction here is going to be rejected, or it rolls back, it aborts. And in that case, this transaction will be accepted. Let's watch what happens when we commit. So I hope that people get the intuition here. So the reason why it's doing this is that there's a write conflict here. So they're both trying to write the account for Blair, right? Right? Okay, so when I basically go in here and I say, okay, the 850, yeah, I'm going to commit that. Boom, it's committed. Great. Now, if I look at the accounts here, it's 850. Okay, so that's the global version of the database now. It's 850. But let's go back to this bad boy, and we'll look right here, and we'll basically try to now the lock was released finally, and we try to do commit. Oh, what's wrong about that? And what's the account going to be? 875. And what's the account going to be over here? 875. So it looks like what it did. Well, we're going to get some interesting behaviors here. Why doesn't the second just make a private copy and then make use of the first committer wins? So it's not first committer wins that PostgreSQL does. It's first updater wins. So we got read committed here. Okay, so under read committed, let's first of all show something that. Let's just experiment with this because we're trying to develop our intuitions about how this kind of stuff works. I was already wrong about one thing, and that was the expected. Now, the locking behavior was understandable, but what I don't really quite understand is, well, let's get to the bottom of it and see what happens here. Let's just do some experimentation to see how it works. I'm fairly certain it's implemented correctly, so it won't be like one of these things where I said, oh no, I forgot to set the proper isolation level under C-phrase. It's not going to be like that. That much I've tested, so this should be working. Let's just verify the whole kind of read committed thing. So let's commit this guy and let's commit this guy. Okay, so now we got two fresh ones, right? So these are both running separate transactions. And let's just go in here and let's basically say, let's look at the accounts, and let's then let's go here and let's look at the accounts here too. Okay, so we got 875 and we've got 875 here. Okay, so I think I know what happened here. Now with read committed, I'm going to go in here and I'm going to change Blair. I don't mean to pick on. Well, actually, I do mean to pick on Blair. He's an asshole. All right, let's put in 910. Okay, and now I'm going to save that. I'm sorry, that's going to be done. So, okay, so 910 is in our private copy here. Notice over here, if I do a read, 910 is not showing up. It's still the old copy, right? Now what I'm going to do is I'm going to commit this. All right. So now we're going under read committed, right? So what that basically means, it means now when I do a read, we're still in this transaction here, the second one, we're still in that transaction. If I do a read here, then yes, I'm able to do I'm able to read the committed version of the new, amount that embezzlement amount of Tony Blair. All right. So does that make sense? So that now let's just verify something here. That is not going to be allowed under serializable. Okay. Because serializable, it's gonna let's just verify that serializable will not let that happen. All right. Because the idea behind this all, of course, is that when there's no real serial schedule where you would just kind of be able to read the committed data from the other one, and then yeah. So serializable is most certainly going to disallow that. So let's just go to serializable, and let's verify that. Okay, so we're going to rerun both of these. Are going to now be running under serializable. I have to essentially get to a kind of initial state. So they're both in the committed state here. So now if I say, let's read the account, and let's just verify that we're in serializable on both of them. Serializable, good. And we go over here and we're going to read the accounts here. And then we see that we're also under serializable here. Okay, so now let's do the following. Let's say that now we go here. This is the first transaction, transaction one. I wish there was like an easier way to kind of to indicate that, but I hope you guys are following. And what I'm going to do is I'm now going to set the amount that Tony stole up to 1,000. Okay. Now, in the local copy here, we have 1,000. Now, let's commit that. Good, that's committed. Now, if I try to read it here, it should not allow it. It should not allow, because we're still in the middle of this transaction here. So see here, now it's still at 910, okay? Because it's not allowing us to, so it's not allowing us to read from anything that started after we started, okay? Well, it's not allowing us to read anything that didn't commit before we started. And obviously these are concurrent transactions, so we can't read the results of transaction one. So transaction one, it's all fine and good. So by the way, this is a new transaction now, because after I commit, then it starts a new transaction. So this one just started here, okay? And it's got 1,000, and it's got the 1,000 in there. So what happens now if we basically try to say, all right, we've read these things. Now let's say that we look at this and we say, all right, let's say we had the following logic that said, I mean, all we've done is a read here, right? All we did was a read. And let's have the following logic. Let's say that let's only add money to DSK's account if Tony's is under 1,000, right? So this is kind of going to get us into this kind of anomaly. So that cannot be, that's going to cause trouble. So I say basically this, I say that I'm looking at Blair's account, it's 910 according to me. Whereas actually in truth, at this particular moment in time, the amount is 1,000. But I'm just going to say that if it's under 1,000, I'm going to add 100 to Dominique Strauss-Kahn's account. Okay. So I go in here and I edit Dominique Strauss-Kahn's account, put that up to 1,000 because that was the logic I was using. And now look, it doesn't, it's smart. So it realizes that I did some reads here. And I was reading some data that's out of date now. And it has no idea that I'm using this logic in my head about like this this principle that I will only add money to the account of DSK if Tony's is not yet 1,000. Because they're a team together and need money to go do something crazy. All right. That shows us that serializable is really working. Okay, serializable is really smart in that way. Does that make sense to people? I hope that it's really, and I'm going to kind of develop the example a little bit more to try to give you guys really kind of a deep intuition about why serializable is so damn good. And we're going to look at this. Okay, so again, remember, serializable in PostgreSQL is snapshot isolation, serializable snapshot isolation. Will the second one not read the update? I don't know. When will the transaction 2 not read the update? When will transaction 2 not read the update? It won't read the update. We're talking serialized. We're talking about in serializable. It's not going to read any update from anything that didn't commit before it started. So it's really, really stringent about what it's going to read. And this really is kind of, one would say this is almost poisonous, because what the read does when you're reading old data, it basically implicates any potential write that you might make later, because you could have used the knowledge of what you read and be, like in this, this Tony Blair case, this Tony Blair and DSK kind of getting together for a party weekend kind of case, that you could only, once you do a read of something, it makes it so that you're more likely to have to be aborted when you're running under serializable. So reads, like broad reads across the whole database, it's really, really quite sophisticated here. So broad reads across the whole database really make it likely that you're going to need to, that you're going to be reading some data that somebody else updated and they committed before you, and now you're basically going to have to abort, roll back. All right. Let's see here. So when it did it right here, so when it said could not serialize this right here, let's see, what did that do? Okay. So no, it might succeed a free try. So basically what this is basically saying is it's saying that, okay, it doesn't like this. So I have to roll it back. So I'm gonna roll it back, and now I can go back in here. Oh, now I see that Blair already has 1,000, so I'm not gonna give any money to DSK, right? So if the logic of transaction 2 was simply saying, hey, if Blair doesn't have 1,000, then I'm gonna add money to DSK. Now it's being respected. Makes sense to people. Okay, we're gonna play around with this a bit more, but it's kind of cool. I mean, it's kind of fun to do this. You'll get a chance to do this in recitation to kind of play around with yourself. I mean, if people want to use, I think using C phrase for it is really good, but it's kind of the things I've just added the functionality, so it's kind of not. I don't know if I can. If people want to do that, they can talk to me and I can give them a copy. But it's like, I mean, I have to kind of patch. I have to make sure that it's robust, but so don't robust under some other aspects, make it more user friendly to do these experiments. But let's do now. Let's take a break. And let's just come back and let's just play around more with this and kind of like try to tease out really kind of the magic of how PostgreSQL is doing this. And remember, this stuff is so much more sophisticated than kind of like file system locks and operating system kind of mutex on threads and all that. I mean, this stuff is really for real. I mean, this transaction stuff. So you can really kind of get some really, really kind of deep behaviors that are kind of the right behaviors out of this. And then, as we'll see also in the examples, if you don't do it right, you get the wrong behaviors or behaviors that make you susceptible to problems. Okay, so let's take a break and then let's get back at 15 after. Okay, all right, I'll see you guys. Unfortunately, I need to kind of go into the university. Anyways, why don't we say, let's come back at 20 after. I gotta, 20 after. That might make it easier. No, I'm sorry. Just because I was kind of didn't really start class in time. Let's make it 15 after. So let's say 11:15. Let's come back and then I'll just pause recording here and then we'll resume. You are right. I was muted. Sorry. So what I showed before is just when I flashed that is that I've decided that I got the schedule a little bit more settled. So go to the web, of course, and look at the lecture, and you'll see the slide. So the 26th is when the quiz is going to be. All right. And yeah, so it's just, and I moved up the last project meeting just a little bit, maybe from a Friday to a Tuesday, and then I put the recitation number 4 on the Friday. So just check that out. So I think we're kind of moving along at a pretty good cruising speed here. I'm going to, I'm kind of repeating myself here. I'm going to release recitation number 3 later today. So sorry, I kind of got delayed a little bit. All right, so let's get back to this right here. And I wanted to talk about serializable. So generally speaking, you want to use serializable because serializable is really pretty, it's tight in terms of like how information could be being passed between transactions. And it gets you in a really kind of intuitive state of, well, it was done in a serial order. So let's take a look at this right here. Let's just verify we're under serializable here. And indeed, this guy right here is under serializable. Let me just kind of get these guys set back to their start state. Commit there. Okay, yeah. So watch this. So transaction number 1, we'll call this transaction 1. And I hope people are following along here. Submit. So we just did a read of all 3 tuples of the accounts table. Okay, we just did so this guy right here is in some sense polluted by this knowledge, all right? And likewise, this guy is as well, okay? So now there might be something like, well, we'll add somebody based on whether Blair has, whatever condition we want to put over it, but we've seen the information now, okay? Now what I'll do here is I'll just simply add account and I'll give it an ID of 4, okay? So this is an account that has an ID of 4, and I'll put in the owner as, say, Hunter. And let's give Hunter, he's doing pretty well, 1100. Okay, so now Hunter is being added now to this database here, okay? So, and likewise, so now this is just repeating that. So basically, if I just say, let's look at the accounts, we'll see that Hunter's in there now as well. And obviously, since we are running under, serializable, we go in here and we see that Hunter is not there yet, okay? All right, let's add an account, and let's just assume that we're kind of giving things IDs that are, well, we're kind of getting unique IDs, or we don't, if I said account number 4, then we know we're going to get some kind of collision because it's going to be a problem with the primary key. So let's say account, let's give it account, add account with ID 5, and let's just make that Papa Joe. And let's give Joe an account amount of 0, let's give him 12, a little bit in there. Okay, so now we have Joe. So we've added 2 tuples, right? So at one level you would say, well, these aren't touching one another, right? So I should be able to then just, so let's commit the one here with Hunter. Okay, so now it's in there. And if we read this here, now we see that Hunter's in there. And now let's try to commit this one here with Joe. And it doesn't like it. And the reason why it doesn't like it, because there's no serial schedule that, based on what we had read and made a decision to put in Joe, and based on what we read and put in Hunter, there's no possible serial schedule that reflects that, right? Okay, there's none of them reflect that. So it's going to block us from doing that. It says, okay. And all right, so it really doesn't like it. We're just going to roll it back. Okay, so now we're at the beginning. Let's put ourselves back in the beginning of both. But now, of course, what we have here is we've lost, so if you look over here on account here as well, we've also lost, we wind up losing Joe. It just didn't go through. We could re-add it now if we wanted to, but it didn't make it through, which is what we wanted. All right, so now let's do the following. Let's do this a slightly different way. Okay, let's do this where we're not doing any reads at all. And for me to do that, I'm going to actually have to restart everything. Okay, so I go back here. I'm going to give myself 2 fresh transactions. So transaction 1. And now I'm getting a little bit nervous because C-phrase might have done something where it did some reading, but I don't think so. So we have transaction 1 and transaction 2. And what I want to do is I want to say add account ID 4, ID 4 owner Hunter, and amount 1100. Okay, And over here, let me just copy that there. Let's give his daddy, Joe, an amount, and let's give it an ID of 5. Let's give that a, let's give him no more generous here. Let's give him 100. Okay, so now, provided that, so there has been no reads. We're just doing a kind of a blind write here, an insert, right? So I'm going to add account ID for a Hunter. So, okay, insert account amount ID for here. All right. But, oh, wait a sec. All right, so we have a little bit of a problem because I think I already had Hunter in there. So who's another? Let's put somebody else in there instead of Hunter. Let's put in. Let's put in King A. And let's give him account number 6 here. Okay, so now we're adding King A for 1100, and we're going to be adding Joe for 100. Okay, so now we submit that, and of course we have to say ID 6. Okay. The reason why this is happening is because once you get in a bad state, it doesn't like it. So we need to take this back to the start. And based on that, what we can do is just roll back here. Based on that, what we can do is we can actually go in and we can delete Hunter here. So I'm going to basically go. Or do I want to do that? No, I want to basically go back now. I'll say roll back. I'll basically what I want to do is I want to put in King A for that. And now when I do that, it should be fine. Okay, so King A is coming in, ID 6 and King A came in. Boom, he's in there. And unfortunately there was, okay, then there was a read, which is kind of not what I wanted to have happen. Sorry, it's the important point because C-phrase is kind of doing some stuff that's doing extra reads. So what I want to do is let's just take it from the top here. In fact, let me just do a little bit different. And let's just kind of go back to the original example. We have Hunter here. Let's just delete Hunter. So I'll just say delete account 4. Okay, and then I'll commit that. All right, so let's just make sure here. Account. All right, so there's only 3 of them now. Okay, so great. So now let's go and let's just basically restart everything. So now we have one transaction, and we have another transaction. Okay, transaction 1 and transaction 2. And this is what originally I wanted to do. I wanted to say add, so that no reading has gone on, which is the important part here. Account, owner, Hunter, amount, 1100, and owner, amount, and ID is 4. Okay, and then likewise, I want to then have his daddy in. So let's put in Joe and give him an ID of 5. And let's just have 110 there. Okay, so now neither of these transactions, transaction 1 or transaction 2, have done a read of the database. Okay, but they're both going to do a blind write. Okay, so he's going to come in here. We're going to submit this. This is just a C-phrase thing, resolving ambiguity. So ID is equal to 4 here. So boom. So in that goes, right? And then we're going to go over here concurrently. And there, and in he goes. Now we're going to commit this one. And now we're going to commit this one. They're both committed, okay? So I hope that you understand kind of what happened there. That's pretty cool. Because you didn't read anything and you were just doing kind of a blind write in, which would make some sense in certain places and contexts. Because of that, there was no conflict was detected on your read logs, your read and write logs. Okay, so basically, basically there is a serial schedule that could have realized this, right? Think about it. I mean, there absolutely is a serial schedule that could realize. We just did 2 operations. One is just to add Joe. The other one is to add Hunter. Just as back to back. We could have been add Hunter first and then add Joe. It doesn't matter. Each way would have gotten us to the basic same result state, which is now we're going to see that both of them are in there. So both Joe and Hunter made it in. Okay, but realize, had we done that, but the first thing we did, so that works, right? But if we do a read of what the accounts are first and we read them all in, and then base our decision of adding Joe or adding Hunter based on that, then it's not serializable anymore. All right. So it just shows that doing these reads can make it so that you wind up, you wind up registering contention about what could potentially be a serializable schedule. All right. Now, that business of us, if we have some kind of unknown logic where we're basically saying add Hunter if Joe's not there, add Joe if Hunter's not there, then this, of course, we would not want to have this happen. So that happens under serializable. But if we go now to our other friend, which is repeatable read. All right, so remember, repeatable read, and if I relaunch this, it'll relaunch both those. So remember, repeatable read is the idea that you don't, like, every read that you make is always going to be the same. You always get the same result for the read. All right, and I'll show an example of that as we explore this right here. But repeatable read also under PostgreSQL is exactly that that initial snapshot isolation, the one that is not serializable snapshot isolation, but just snapshot isolation. All right, so it's got that weakness in terms of doing the reasoning or kind of potentially being included. So under that, let's say now let's repeat all this right here, and let's just kind of take it from the top here and see here. We have well, I should have actually done something else there. What I should have done is I should have cleared out our database. Let's say let's be a little bit fair here, and let's get for real here about who are the people involved here. All right. Okay. Yeah, whatever. Okay. So what I want to do now is I have Trump, and let me just add in add account, and I'll make it an ID 6, and let's give that person the name of Jared, all right? Because they're all crooks. Let's face it. 230. So Jared has 230. Okay. Let's actually say Trump. Okay. If Trump is over a all right, here's what we're going to do. We're going to basically have the following example we're going to do. So we're going to do a little bit different example just so that we stay in accordance with the other ones. And I can just get rid of these guys just so that we, let's see, I don't want to do it that way. I want to do it this way. Delete ID 4, 5. Okay. Yeah, all right. So that's a C phrase thing. 4, sure. And then 5. Sure. And then let's commit that. Okay, so now when we look at the accounts, we're going to see that we don't have those guys. We just have our original 3 here. And let's just for the time being, let's just delete Trump. Delete account Trump. Okay, so we just have Blair and DSK here. So let's have the following logic. All right. Now we're going to run under what we're running under here now is we're running under the repeatable read, and what we want is the following logic, and that is that when we here, let me just get rid of that guy. I'll just restart him. So here's how so this is basically the middleware, by the way. This right here is running the middleware that is thread safe, etc. So this middleware that's running can have multiple threads inside of it, and of course you need that because otherwise, well, you can't put async over the whole thing. It'll cause so that you're not going to get transaction behavior anymore. So it needs to be multi-threaded. Otherwise, it won't work. Okay, so what we want to do here is that here's the rules of the game. Here's how we're running. We're running under repeatable read, and if Trump is not there, we want to add Jared and give Jared 1,000. And if Jared is not there, we want to add Trump and give Trump 1,000. Okay, and we only want to have Jared or Trump in the database. Okay, so Jared, adding both is not what we want. So we really want to represent the family. Either under Jared or under Trump. And in the first case, we're going to basically prefer, Trump, another one we're going to prefer Jared, but we would prefer under that if the one is already there, then we don't want to add it. So that's kind of the rules that we're going by. And we're going to show under repeatable read how that gets violated. So we got one that's going to fire up, and we're going to fire up another one. Okay. So now I say basically, so I first of all, I do a read accounts, and I basically say, oh, Trump is there. What's Trump doing there? Delete accounts Trump. Okay, now there we are. So we have that commit. Okay, and let's see here. Now this right here actually should give us. Yeah, so this gives us so just started there. So this transaction just started. It got Blair and DSK, and this transaction is just going to start, and it's going to have us Blair and DSK. Okay, so in this one here we're going to add Trump because Jared is not there, and in this one we're going to add Jared because Trump's not there. But remember, we don't want to have both Jared and Trump there. That's so if we were to run these under a serial order, then basically we would see here we would add Trump. Okay, so let me just add a Trump. Add account, and let's say that ID 3 for Trump, and Trump, and the amount is going to be 1,000, whatever. All right, 1, 2, 3, 4. Okay. Now, if they were under a serial, then this would then commit, and then when you read in here, you would see Trump there, and so you would not add Jared, right? But we're running under snapshot isolation, so what we're going to do here is we're going to say, oh, okay, now let's add in Jared. So I'll say add account. ID 4. I did ID 3 here. We know we're going to get in trouble, right? It's already going to cause a problem. And that would actually solve the problem because it's not going to allow for the primary key. ID is a primary key of the table, so it'll automatically cause trouble that way. But let's just go in here and let's say Jared, and let's give Jared 432. Okay, so now Jared's in there. So now the issue is that under serializable, we could not commit both of these. But under repeatable read, we're going to see that we can commit both of these. So let's commit Jared, boom, and let's commit the one with Trump, boom. Okay, now if we go back and take it from the top, we're going to see that both of them are appearing. And that was not the behavior we wanted. So we could never get that behavior under a serial schedule, but we can get it under snapshot isolation, right? Under repeatable read. Now, let's explore the last thing about repeatable read, and that is to say this. Okay, these are both in the start state of repeatable read. Okay, account. They're both in repeatable read. Now, I'm going to basically say add account, and I'm going to basically say the owner now is going to be who have we not picked on yet? I did King Abdullah. I don't know. Well, there's a lot of people to pick on, I'm sure. Let's go back to King Abdullah. King A there's the guy from Kenya. So this is this Pandora Papers, by the way, if anyone knows, I'm making reference to that. Okay, if I go here and I add this account here, that's going to be King Abdullah is going to, oops, doesn't like that. Account ID, I think it needs the ID. The serial got screwed up somehow. ID 7. Okay, King Abdullah. And let's give him that amount. Okay, so now King Abdullah is there. So now because it's under repeatable read, remember back, oh, I see why it happened. Back here, when this guy started here, this is what the state of the database was. So he's always going to see the state of the database. It's not, even though, so it's a repeatable read. So I haven't committed here. This guy in the meantime is going to commit. And he committed, right? And now I'm going to go back here and rerun this. And it still is giving us the same thing. So the idea here is that since it's doing it under repeatable read, it stays constant the whole way through, right? So that's the kind of the point behind a repeatable read. But as we've seen already, it did allow us to have this kind of strange non-serializable schedule go through where we added both Trump and Jared. Okay, so so it's got its weaknesses there. So now. So, I mean, generally speaking, what you want to do, I mean, what you wind up doing, I assume that if there's Michael Stonebreaker, I think it was Michael Stonebreaker, who said that anything other than serializable, anything other than I got it, analyzable. Anything other than serializable is beyond any mortal to understand. The behavior gets so complicated. All right. So the only one that really is always you're going to be intuitive about is serializable. All right. Now, since these guys have now restarted, they should both be under serializable. All right, that's not what I wanted to do. So that they're both under serializable here. Account. All right. So we have serializable. Okay, so now, so these guys are going to go through and do their thing. So both of these should be the same, right? They are the same here. And what you'll see, so these a lot of times, this is the way this works, is that these are kind of like the transactional transactions. These are transactions that are kind of doing with money transfers and stuff like that. But then let's say we have another transaction off to the side, which it's going to wind up doing, what it winds up doing. And let's just go through here. And okay, so here, let me just show you here. This is one server, because I have to do that on the server. This is one server, this one right here, running on port 8000. This one here is running under serializable, right? Let me start up another one. And the way I'll do that is I'll just go into here and I'll change this to, let's just basically change it into auto commit. That is, remember, that's just the easiest one. That one, there's basically no transaction processing whatsoever. So I'm going to save that. I'm not going to rerun these because I want this guy to, I want this guy running on what was it, 8000? I want him to be serializable. He's running all the transactions running that access this one here on port 8000. All of those are running serializable. But what I'm going to do is I'm going to start up a fresh one. No, I'm going to start up a fresh one, and I'm going to run this one on 9000. Okay. Now this one, when it ran, it was using the actual the new setting here of auto commit on isolation level. So what you'll see here then is you'll see that basically what we have is we have two transactions up here running here. This guy and this guy. These both are running under serializable, right? And this one down here, this guy right here, so the third one over here, or first one actually, the one running under 9000, this one is running basically under no isolation level whatsoever. It's just basically, it basically goes to whatever the current version of the global database is. Now, both these transactions have started, right? So now if I go here and I say something like this, let's say, the amount for Blair, let's say that Blair, I don't know what Blair does for fun or whatever, but let's say he goes and he spends up some of that money. So so Blair is now down to 900. Now, if we go back here though, and we look at accounts, of course, it still is Blair is still at 1000 because it hasn't committed yet, right? Because we're dealing with serializable. So now let's go back here to where Blair was at 900 here, this guy right here, and let's commit that. Okay, so it just got committed. So now, of course, if we go to this other one here under serializable, and we look at accounts, Blair is still at 1000, right? But if we go here to this basically running under auto commit, then we should actually now get, and we get the updated value for Blair. So the idea here then is that this is very common. You'll have like some kind of analytics process that's running under a more relaxed transaction level, because all it needs to do is just kind of sum up how much money we have on hand or whatever it might be. So when he runs, he's just getting kind of what is the current version of the database, boom, 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 down the line, right? And that's because he's running under a lesser isolation level. If you ran him under serializable, then you, of course, would be in a world of trouble when it came. What would it be? What if you ran him under serializable? I don't know. Maybe actually wouldn't be that big of a deal. Maybe because actually, if I think about it, it could probably be okay. Yeah, it probably would be a big deal. You could probably do it that way as well. But what you'll see a lot of times, you'll see that what you wind up doing is you wind up having some of these transactions off to the side that are let's see, what is the deal with it running under? So if you ran it, it depends. Let's see, how do you think? If it's a repeat, so, well, I don't know. The thing is, what I'm trying to get here is if you restart the transaction every time, then it shouldn't make any difference if you're running under serializable or you're running it under, or you're just running it under auto commit, or you're running it under like read committed or something. But if the actual transaction itself, the connection for that transaction doesn't get refreshed, because what cphrase is doing here is every time I relaunch it, it's doing a refresh. So you'll probably have to put it under a lesser isolation level if you want to maintain that same connection and have it read off of what the evolving state of the database is. I hope that makes sense. So I would like to say, and I think that if we were in person, I think the people would be asking questions now, but I don't think anybody wants to. So ask a question in the private chat if you want. But maybe we're not going to. All right. So let's see. So where does that leave us then? It leaves us with just kind of me specifying recitation number 3, and then having you guys go in and play around with these and do these experiments yourself as well. But I hope that at least I impressed upon you the power of serializable. But again, serializable is going to have, you're going to have more restarts under serializable. It's more finicky. It doesn't let you through. And again, remember what I was saying before is that we have 2 types of transactions. And what we've been exploring in these examples we developed here, we were exploring kind of the human driven and decided transactions. So in other words, restarting one of these is more painful because it requires me to go in and kind of look at the state of the database again and fiddle with it. But a lot of the transactions that get run in the real world are already they're automated already. So restarting them is kind of a triviality. You don't have to worry about bringing some human being's attention to it or having it. So just that's just something to keep in mind that there's kind of that distinction. So, all right. I think because I have this, I think we're going to maybe just leave it there. Unless there are any questions. I hope that this at least was somewhat educational. I'll post recitation 3 and then just ask questions about this if you get it. Let's see what else to say. All right. So basically, let's talk a little bit about projects. So projects, I want to just basically people can start if they want to start booking now their project meetings for later this week. They can start doing it now. I just want to kind of go over like kind of those, and I'll send out a message about this. But basically, I just want to kind of go over like, or maybe I don't even need to send out a message. But if I can look at some of the planning documents, that's kind of good. But it's mostly just to kind of ask you guys like, well, what is the status? How? Because by now, I'm assuming before you meet with me, I definitely want you guys to have actually attempted to do some work on your project. So you kind of have a much better idea of what the risks are. So most of what the discussion will be later this week, potentially on Friday for a lot of you, is kind of trying for me to probe out what are the risks in your project? How's it going? Does it need to have some kind of restructuring, or do you need to kind of reformulate it or something because you've already noticed that it's like problematic or something? Or just kind of like, if you can get the whole if you can basically have the project done, that's great. I mean, so if it's, we meet the first meeting and you say, hey, bam, boom, it's done. Then I'll say, all you need to do now is just put some polish on it maybe. But yeah, you're in great shape then. But that'll come out when we talk. So, okay. All right. So I'll talk to y'all later, and I'll stop recording now, and goodbye.